Hi, good afternoon. It's Dean from the Maverickstar Observatory. Guys, we're going to be taking a quick look at the TriMag data. It's a day late. Usually we pop the SD cards on the 17th, but I thought yesterday was well worth mentioning to you how things are with regards to the restriction on freedom of information and on the basic human rights infringements that we're all suffering with. But nevertheless, it is time to go and have a look at the latest magnetic pole position and check out the TriMag data and the Magnetosphere data shortly after this. But before we do, big thanks. Obviously we have got through to a few people. We have managed to get a little bit of funding going over the last couple of days, so that's amazing. It's a little glimmer of hope, because all I can say is this month has been a real slow start. So at least things are showing promising signs. We've raising a few bucks for the observatory this month, and let's hope that continues. So big thanks to our patrons, our superstars that look after the equipment around the world, and a big thank you to those that make those one-off payments on PayPal. So let's get into it. As you can see, we've got a few bumps, almost breaking the 13 degrees mark on the TriMag data. And if you remember, it wasn't that long ago when we was breaking just almost the cusp of the 12 degree mark, and it won't be long before we do see the very first 13 degree mark. When that happens, I'll show you the raw data that we collect. Obviously there's a lot of data that's collected with the TriMag system. That's because we monitor it on a very small resolution of every 3 seconds. Some people have criticised me, saying that is there any need for that sort of resolution, but I just want to make sure that this time round, for the first time in human history, we have made sure that we've done everything we could possibly do. And if there is something that happens on an interval of a third second, we've got it. And this will be the first time that the magnetic pole migration has been monitored at such a resolution, because I'm pretty sure that NASA, NOAA and the European Space Agency do not go anywhere near a 3 second interval. We collect, like as you can see, 300,000 separate data parcels every month, and that's millions a year. And we've collected this now for a couple of years, 24 hours a day, 7 days a week, 365 days a year. That's a remarkable archive of data on this anomaly that is taking place for the first time in 780,000 years. So I think it warrants that level of resolution of every 3 seconds. Let's go and have a look at the Magnetosphere Sensor. So here we are on PoleShift News, and as you can see, not a lot has changed. But this is it, guys. This is what I try and always say. We've got the equipment monitoring it. It's not always going to be like this, and as you know, when things start to pick up, we're going to start to see that line going up and down crazily as we get close to that 40 degree mark and we start to enter the weak field lines. But we have the equipment in place to monitor it, and it's very easy to take it for granted that not a lot has happened, even though there's a couple of bumps where it's nearly touched the 200 on the scale on the left hand column. That doesn't mean to say that it's always going to be like that. Like I say, when we start going into those weaker field lines, we will see a decrease in the magnetosphere strength, and as a result we'll start to see more activity. But we have the equipment in place and we're recording it, and even though it's not moved a lot over the last year or so that we've been recording the magnetosphere data, it is an archive, just as it is the TriMag system. So let's have a look on Google Earth where the latest magnetic pole is at this current time on the 18th of August 2020. So here we are with the latest magnetic pole position, and the longitude is 83 degrees north by 34.43.79, and the longitude is 125 degrees east by 33.50.16. So if you're following us on your own Google Earth, marking these positions, you've got the latest coordinates of where the magnetic North Pole is. I'm just going to zoom out so you can see where we're going with this. Let's just keep that, and we'll carry on zooming out so we can see where, you know, things are and where we're heading. As you can see, there's our corridor. We know where this is pointing to. You can see the 40-degree mark. Let's just see how far off we are on the 40-degree mark. So in miles, we'll measure from this point to that point, and we are about 149 miles off that at current speed of about 4 miles on average every month. So that gives you an idea of how far we are away. That's why I say we're probably 2-3 years away from the 40-degree mark, 7 at the max if things slow down. But I do predict that as we go further into this magnetic pole reversal and we get closer to that 40-degree mark, things will start to pick up. And the reason why I believe that is because, you know, we have seen from the experiments we've conducted that as you go 40 degrees over on any compass, once it goes over 40 degrees, it gets into the weak field lines, leaves the strong field lines where things move relatively slowly. Once it gets into those weak field lines past the 40-degree mark, things should start to get and take place a lot faster. So we're just going to continue zooming out so you can see the corridor of where the magnetic North Pole has been tracking over the last 100 years. And remember, as it's been tracking over there the last 100 years, it's been migrating faster and faster, covering less distance in shorter time. But we know where it's heading, to this pinpoint here, and that is somewhere just below the Arctic Circle over the northern hemisphere, almost central Russia. And that is where, you know, our corridor is and has been for many years now, tracking, as you can see. So that's the latest update on the magnetic North Pole. Tomorrow we do the global health check where we incorporate atmospheric oxygen with our sensors that we've got here. We really throw the boat out and you know, try and cram in as much information with regards to the world's health. You know, things like earthquakes over the last week, the amount of active volcanic eruptions that are in eruption, not just showing signs of eruption. You know, we include you know, muons in the UK. We'll also be including now the muons in the Gold Coast, and when we do get into Brazil, we'll be putting those up on the global health and a lot of other things, guys. So tune in tomorrow for the global rundown on the condition of the Earth and its health. And you know, there's not much else to say other than, you know, guys, there's a link down there if you want to become one of our patrons. You know, please do. If you want to one-off support us, the link's there on PayPal. But more than anything else is keep this observatory running. You know, it's a private public, well, it's a public funded observatory, and the only way we can keep that going is by public funding. Simple as that. There's no need to mention anything else other than the fact it's not mandatory, but you know, we will come to a halt, guys, here if we don't get funding. As a little bit of a bonus, I might include some videos on a little project that I'm working on the side. I just want to see if it's possible to use, you know, ordinary microwave equipment, not just to generate plasma, which we know we can do, and I'll show you that in tomorrow's video, but also if it's possible to convert the equipment that's in a microwave using some, you know, strong magnetic electromagnetic coils to contain a plasma, and at some point introduce methane gas over a seed diamond to grow the diamond. So you know, it's exciting stuff. I've been messing about with plasmas over the last couple of days with an ordinary household microwave. I'll be pulling a microwave to bits over the next week, taking the magnetron out and building the apparatus I will need for the, you know, the research into making laboratory diamonds. And I'll tell you why I'm going to see if I can do it, because if it's possible to do that, I don't know whether you're aware about laboratory diamonds, but Laboratory diamonds are indistinguishable from real diamonds. You know, you put a laboratory diamond in front of a diamond expert and he will not be able to tell the difference between a real diamond and a laboratory diamond. So, you know, I'm interested to see if I can create a laboratory diamond in my spare room using microwave frequencies and methane gas. So, you know, I'm sure you're going to be interested in this as a little bit of a side project. It's not really anything to do with Pole Shift News, but, you know, it is exciting. And, you know, I'll show you the first steps on the way to that tomorrow in a video. So, yes, guys, link down there if you want to support us. And as always, guys, you know, you take care, look after your loved ones, and I'll be back tomorrow. As always, bye for now.